Hello, welcome back to Cinderella Math. Today I'm going to be doing a few examples with the topic of how to solve a third degree polynomial where we are already given one of the answers. So we've got one solution, we need to get the rest. All right, and this will be needing the skill of synthetic division. So if you don't have that skill yet or you want a little brush up on that, look on my channel and you will find a separate video on polynomial division. Feel free to kind of review that one first if you need to before coming back to this one. All right, so let me give you a third degree and I'll give you one answer and we'll get the rest. So here's example one. We have a function. All of these are going to be third degree or cubic functions. All right, it is set to 0, so the directions are solve. But they tell us x equals 2. So that is one of our solutions, also known as roots, also known as zeros. We need to find the rest. How do we do this? We're going to take the number that they have provided, that first solution, or 0, or root, whatever you want to call it, whatever your teacher calls it, and you're going to put that into synthetic division. I call that the timeout box. That number goes in the box. And then take your coefficients from your original function. So this is a 1. Careful, we have 0 x squares. We do need to put in that 0. -7, 6. Don't worry about the equal 0. That does not need to go in part of synthetic. Just the coefficients of the regular function. Drop down, multiply, add. Multiply, add, multiply, add. Okay. You should get a remainder of 0 on that because we already know that this is a solution. If you do not get a remainder of 0 right there, then either I have lied to you and that original number is not a solution, or we've slipped something up in our synthetic. But we have gotten a remainder of 0, which is good. And now we take what's left over. We take this result to get the rest of the answers. Don't worry about 0. He's a remainder and he's gone. This is a constant. Give this an x. Give this an x squared. So kind of work your way backwards from right to left. This is our new problem. We have 1x squared plus 2x minus 3. We need to now factor that and then solve it. So technically we are setting equal to 0. I factor with the magic X method. If you use a different method, that is totally fine. There's also like a box method, a grouping method. I just think this is the easiest. I don't have a separate video as of right now on magic X, but I should make one. So we'll look for that coming soon. I take the first number and the back number. So basically your A and your C of this quadratic. 1 times -3 is -3, and the middle number, or the B, into the bottom. I call it magic X because there's M here, A here, MA for magic. We need to multiply to the top multiply to the top, add to the bottom. So go through your times tables. What would multiply to -3 but add up to 2? That would be 3 times -1. Multiply those together, you'd get -3. Add those together, you'd get +2. So those are your magic numbers. And now we're going to set up our factors. See this x squared, the one's not super important. 1x for you, 1x for me. And then our magic numbers was +3 and -1. If they were just asking for the factors, that would be the factors, but let's set to 0 because they're asking for the solutions. This would come over and be -3. This would come over and be 1. And then don't forget about the solution that was given to us. That still counts as well. Get that in the list as well. Squiggly brackets because it is a set of solutions. And there we go. So we took the one that was originally given to us, worked it through synthetic, which resulted in a quadratic, which we could then factor. This is checkable through your graphing calculator, or if you use the Desmos online calculator. I'm not going to switch over to that, but if you wanted to check it, type this in, and I would not put in the equal 0. I would just do the original function, and you will see the cubic function crossing something like that. It's not going to be perfect, but it's going to cross the x-axis at -3, 1, and 2. That's how you could check it on a graphing calculator. You don't have to, but if this was like a test or something, you could. All right, let's do a couple more of those. Here's example 2. I have x cubed minus 28x minus 48 equals 0, and they tell us that x equals -4. So that is one of our answers. We're going to put that answer that they told us into synthetic. There's a 1 here. Be careful, there's 0 x squares, just like in our previous example. And again, don't worry about this equals 0. Just the coefficients of the original function. Drop down, multiply, add, multiply, add, multiply, add, and we should get 0. Because again, we already know -4 is an answer, so we should be getting a remainder of 0. If something has a remainder of 0, it is a solution. Now back yourself out of that. Don't worry about the remainder. This one's constant. Give him an x, give him an x square. So this is our quadratic now in the blue. Factoring, take the first times the last, and then the middle. We need to multiply here, add here. Go through your times tables for 12. I think if you did -6 times 2, if you multiplied those together, they would multiply to -12. And if you add them, I pretend it's money. You owe me 6 plus you give me 2, you would still owe me 4. So our factors, see this x squared? Cut that in half, 1 for me, 1 for you. And then our magic numbers was a -6 and a +2. Set that equal to 0. This will switch over to be 6. Set this equal to 0. This will come over and be -2. And then don't forget about that first one that they told us in the problem, -4. Let me just write that prettier. These are our solutions. Also known as roots, also known as zeros, also known as x-intercepts. So again, if you want to run a quick graph, those three numbers, -4, -2, and +6, that's where this function would cross the x-axis. I have a couple more examples. Feel free to pause me and try them on your own once you have the hang of it. Example 3. 2x cubed minus 15x squared plus 27x minus 10 is 0. And they are telling us that x is 1/2. That is our first answer, or the given solution. So we take that given solution, put that into synthetic, and you'll notice this time we don't have any coefficients missing. So we don't have to do any of the zeros. Again, don't worry about the equal 0. Drop down. 2 times 1/2 is 1. 2 1/2 times -14 is -7. 20 times 1/2 is 10. And again, we should get 0 on this synthetic because we already knew that was a solution. If you don't get 0 for a remainder right there, try again. Now back yourself out of it. Don't worry about the 0. Constant. Give him an x, give him an x squared. So we're looking at 2x squared minus 14x plus 20. Factor that, but watch out. I see a GCF, greatest common factor. All these numbers are even. 2, 14, 20. So let's remove a 2. So let's factor out that common factor 2, which will leave 1x squared minus 7x plus 10. If you don't want to put the 1, you don't have to. Let's factor that trinomial. First times the last, middle number, just ignore the 2. He's served his purpose. We need to multiply to 10, add to -7. Go through your times tables on 10. We should get 5 times 2, and let's make them both negative because negative times negative would be +10. Let's add that. You owe me 5 plus you owe me 2. Add that together and you owe me 7. So this 2 just drops down. And then our factors, see that x squared? 1 for you, 1 for me. You basically just cut it in half. And our magic numbers was a -5 and a -2. Set to 0. Does 2 equal 0? No. So that does not result in an answer. Set to 0. This would whip around and x is 5. Set to 0. This would whip around and get 2. And then don't forget the one they started you with, which was a half. Let me write that prettier. Usually we do go least to greatest. It doesn't super matter. It's just kind of nice. And there's your solutions of that cubic or third degree polynomial. And again, if you really wanted to check, just pull up a graphing device or online graphing calculator, and you would see that this hits at +0.5, +2, +5. Boop, boop, boop. Again, that's not perfect. I'm just guesstimating, but it should look something like that. Okay. I've got 2 more here. Example 4. X cubed plus 2x squared minus 3x minus 6. And they're starting us off with x equals -2. So again, that is already an answer. We take that given answer into synthetic as the timeout and then put the coefficients. Yay, none are missing this time, so we don't have to do that invisible, not invisible, but that assumed 0. Drop down, multiply, add, multiply, add, multiply, add, and again, you should be getting a remainder of 0 right there. If not, we're in trouble, but we're good because we know that's a solution that was given to us in the problem. Okay, now back yourself out of this one. Don't worry about the remainder. This is a constant, this is x squared. So really we just have 1x squared minus 3. If you don't want to put the 1, you don't have to. You could just say x squared minus 3. Now that's still a quadratic, but I'm not going to be able to factor that with my magic x as I have been in the previous examples, because magic x requires 3. It requires a trinomial. So this, we're just going to straight up set to 0. Solve. Move this over. So x squared is 3. Take the square root. Take the square root. So x is √3. And be careful, anytime you take a root here, you're going to do plus or minus. So our final result is -2, because that's what they told us. They started us off, and plus minus √3. Now remember, this does count for 2 solutions, positive √3 and negative √3. If you really don't like the plus minus, you could list them separately. -2, negative √3, positive √3. I usually don't. I usually just do the plus minus, but technically both of those are right. Now this is a little bit harder to check on a graphing device. The -2 will be fine. That'll still look normal. But the negative √3 and the positive √3, they'll show up. Like if I went to Desmos, they would show up. But they're not going to actually say √3. They're going to say like 1.73, blah, 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 blah. And this one will be -1.73, la, 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 la. So just be careful there. This is still checkable. You just have to check that that ugly decimal that Desmos or your graphing calculator is giving you is that root. So it is checkable, but just a little more annoying. All right, I think I have one more here for you. Example 5. X cubed minus x squared minus 13x minus 3. That's our function, by the way. And they are starting us with x equal -3. So that is an answer. That can go through the synthetic. Watch out, we've got a 1 and a -1. Don't forget about those invisible coefficients. Drop down, multiply, add, multiply, add, multiply, add. And again, we should get 0 because we already know that is an answer, solution, a 0, a root, whatever you want to call it, whatever your teacher calls it. And then back yourself out of this. This is a constant. He gets an x, he gets an x squared. So we do have a quadratic of 1x squared. You don't really need the 1. It's fine either way. Minus 4x minus 1. So that is a trinomial. So I will try to put that through the magic X where I do first times last and middle number here. I want to multiply here, add here. Oh no, that does not work. There are no numbers that I can think of that would multiply here and add here. I could sit here all day and I'm just not going to come up with it. Okay? So what I can do is the quadratic formula. This is my A, this is my B, this is my C. I'm going to erase some of this to have room. Let me remind you of the quadratic formula. I would highly recommend that you memorize this if you don't have it memorized already. Negative b plus or minus b, the square root of b squared minus 4ac all over 2a. It looks so intimidating, but it's really not. We're just going to plug and chug with our ABC. Now careful, it does say negative b, and ours is already negative. So technically that's -4. No, that's just 4, right? So if your b is already negative, it will turn positive right here because you're negating a negative. So that's going to be 4 plus or minus root -4 squared. So -4 times -4 is 16 minus 4 times 1 times -1 all over 2 times 1. On the bottom, 2 times 1 is just 2. And on the top, if you're allowed to use a calculator, I would just shoot through that discriminant. That is a fancy name for the stuff under the square root. I would just shoot that through your calculator. Or you can do it by hand. Whatever you prefer is fine. And you should get 20, right? Because that's 16 minus 4, because 1 can just ghost, times -1. So that's 16 plus 4. So yeah, 20. So we have 4 plus or minus root 20 over 2. Now, if you put root 20 in the calculator, you'll get an answer, but it will be a very disgusting decimal. It will be an irrational number, and usually that's not what we want. So let's bring 20 off to the side. This is how I simplify radicals. If you have a different method, go for it. But I just make a little number tree. So I know 20 is 4 times 5, which is 2 times 2. And then I just get it down to prime numbers, and I look for partners. This will bond together and a 2 will pop out. The 5 did not have a partner, so he will stay in the root. So this now gives me 4 plus or minus the 2 popped out because they had a partner. The 5 stayed in all over 2. And then one more thing just to make it as pretty as possible. All these numbers are even, ignoring the 1 in the root. You never mess with him, just the outside numbers. So we can divide by 2. Divide by 2, which can just cancel. Divide by 2, which can just cancel. So that would just leave 4 plus, nope, 2, because 4 divided by 2. That would leave 2 plus or minus root 5. And then don't forget the answer they started with. So final result here, we had -3, which they told us, and 2 plus or minus root 5. Again, you can check that through a graphing device. The -3 will be fine. The root ones will be disgusting. Let me show you on this one, actually. If you're still copying that down, feel free to pause me. I'll show you this one real fast on Desmo, so I'm going to let you go. So I'm just going to type that function. I'm not going to put the equal 0. I'm just going to do the original function, which was x cubed minus x squared minus 13x minus 3. And so there's the -3. Let me see if I can zoom this in. There we go. There's the -3. And then this and this. That is what we got. So out of that quadratic formula, we ended up getting 2 plus or minus root 5. So again, that's 2 answers, right? That's 2 plus root 5 and 2 minus root 5. If you type in 2 plus square root 5, that's 4.2, blah, 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 blah. That's this one, the far right. If you do 2 minus root 5, negative 0.2, blah, 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 there it is. So this is still checkable. It just takes a little bit more work to check. And then the -3 is what they started us with. All right, I hope this was helpful on solving third degree or cubic polynomials given one answer. It is possible to do it when they don't give you that first answer. It's just harder. So I'll save that for another day. I hope this was helpful and I hope to see you again soon. Bye-bye.